So you should be okay with the fact that the integral of 1 over x dx is ln of absolute value of x plus a constant. What we're going to do now is learn how to use ln integration for more complicated functions. These are ones for which we need to use u sub. So in order to figure out an equation that I can use with u's, I'm going to write the integral of 1 over, and I'm just going to go ahead and change all the x's here to u's. And that's legitimate. 1 over u du is equal to ln absolute value of u plus c. Now, sometimes things look like this, but often they don't. Instead, I'm going to write an alternative form of this that I think is better. And that is just to take this du right here and move it to the top of the fraction. So what does that look like? It looks like the integral of du over u is equal to ln absolute value of u plus a constant. Now, this is easier to see when we are doing our u sub integration problems. So I'm going to box that one because it's the base one. I'm going to box this one because it's better than the other one. And then the last one I'm going to do is one that I typically talk about in class, and it helps people see it better. This one is the integral of f prime of x over f of x is equal to ln absolute value f of x plus a constant, like that. It's not as formally right. It should have like a d something there, but I like to leave it like that because I think that it helps people see it. So let's do some examples. Example 1. Let's do the integral of cosine x over sine x. Sine x plus 4 dx. Notice, zoom out a little bit. You might just see that it is ln of the bottom with an absolute value. But let me go through this. So notice here, I've got a cosine and I've got a sine, and I got to decide which one is going to be the u and which one is going to be the du. Because sine derives to cosine and cosine derives to sine, or at least negative sine, right? Notice this thing has this plus 4. If I derive this, I get that cosine x. See this f of x equation? This would be my f, and then what's in the top? F prime. I'm going to do it with u sub so you can see this equation show up, because we're going to need to do that as they get more complicated. So I'm going to say let u equal the denominator, sine x plus 4. What is du? Well, it is cosine x dx. Now, just like we did before, you should see that this, along with that, is this, so it'll get replaced with that. And then this, undo. This is that right there, so it'll get replaced with that. So when I do my substitution, I write that this is equal to the integral of what is in the top, it's my du, and then what's in the bottom, it's my u. This guy is that, this, and then this one is that. And then if I just go off my formula that I have up top, du over u gives me ln of u. Well, this is ln absolute value of u plus a constant, which gives me, I just sub my u back in, this green line right here. So that gives me ln absolute value sine x plus 4 plus a constant. And that's my answer. Now, I said earlier in this series of videos that we need that absolute value, right? This guy said it right here. We need that absolute value. Sometimes it's not necessary. Why is that? I only need the absolute value if I have negatives in there. Notice sine of x plus 4, that's going to be, remember, sine x goes like this. If I move it up 4, it'll never be negative, because it only bounces between -1 and 1. So in this particular case, you could write ln of sine of x plus 4, and it would be correct. But it's safe to just write that absolute value every time. All right, so let's do another one. Okay, example 2. Let's do the integral of 4 plus x squared over 12x plus x cubed with a dx on the outside. You should see that the top definitely doesn't derive to the bottom, but the bottom might derive to the top, or maybe a multiple of it. So let's make u equal to the bottom, 12x plus x cubed. Let's find the du. It is 12 plus 3x squared dx, like that. And then I look at that and I say, I got 12, I got 4, and this, if I divide this line by 3, I'm going to get that right there. So du, 1/3 du is going to give me 4 plus x squared dx. And notice there's a parenthesis here that's implied by the order of operations there. So again, this right here is that, and we'll get replaced with 1/3 du. And then the denominator is the u. So I get 1/3 integral of du over u. What's that give me? 1/3 ln absolute value of, what did I have? 12, because this is u. I guess I'll write, hold on. 1/3 absolute value of u plus a constant, which then I'll go and sub my u back in. So I get 1/3 ln absolute value 12x plus x cubed plus a constant. Now you may say, what about that 1/3? Sometimes we will move that in, right? And sometimes we don't need to. In this case, I'll go ahead and write both answers. If this was a multiple choice question on the AP test, I would want to be ready to answer either one, but this gives me ln absolute value. What would a third power? It'd actually be a cubed root of 12x plus x cubed and absolute value plus a constant. So you should be ready to see either one of those on an AP test if it was a multiple choice question. Let's do another example. Let's do the integral, and this one I'm going to run with this one for a little bit in a way that is going to it's kind of there are common errors once I introduce this type of integration, and I'm going to use this particular example or the structure of this example to kind of hit those things. So let's do the integral of 10x plus 1 over 5x squared plus x dx. All right, you look at it, you're like, can I integrate that? Does the bottom derive to the top? And you're like, oh yeah, it does, right? So I'm going to make u equal to 5x squared plus x, and du, well, that is 10x plus 1. Oh, sweet, it lines up with that thing. So this is the integral of du over u, which gives me ln absolute value of u plus a constant, which gives me ln absolute value, what is it there? 5x squared plus x plus a constant. I didn't talk about it in the previous one, but this one, you should see that, like, if I were to plug in, say, like a particular negative value, I could get a negative number here, right? So I do need to make sure I leave those absolute values. So before we get into the next one, I'm going to give you a couple integrals to do. First one, actually, I'll pause. Okay, here are 5 integrals that I want you to do. Why don't you hit pause, do all 5 of them, and then come back and we can check our answers. Answer's going to pop up in a moment, so make sure you've hit pause and you've tried all of them. Pause. Here it comes. Okay, 1/5 x to the 5th plus a constant, easy power rule. 1/3 x cubed plus a constant, easy power rule. Integral 1 over x, ln absolute value of x plus c. That's what we've been talking about. All right, this one, x to the negative 10th. I got to go, I'm in the negatives with the 10, or with the x's. I got to go up 1. Up 1 above negative 10 is negative 9. So I get x to the negative 9th. And I divide it by 9. Sorry, negative 9 plus a constant. And then I shuffle things around and write it with a positive exponent, and I get negative 1 over 9 x to the 9th. So, this one. After I introduce these things with this u sub, people start messing up this. People look at this and they say, oh, it's ln of x to the 5th. No, shake your head, no. When I see this, I still have to use power rule. So this is the same as integral x to the negative 5 dx, which is negative 1 over 4 x to the negative 4th plus c, which is negative 1 over 4x to the 4th plus a constant. So when people learn the ln, they typically start messing these up. But remember, this is power rule. I need to have the f prime on the top. That's why I like this form. Where did it go? It's right. I don't even know where it is. This one right here. I got to have f prime in the top and f in the bottom to do the ln of f, right? And if you look here, I've got x to the 5th. I need to have a 5x to the 4th there if I was going to integrate that to an ln. You can imagine how that might even simplify in a way before we would integrate it like that. So I am going to copy this guy. And actually, I'm going to copy all of this. Scroll down here. What example was that? Well, that was example 3. So example 4, paste. So take a look. What if I give you the exact same problem, but I put some parentheses down here and I write to the 4th? This is where people, especially like say you don't mess it up here, this is where people frequently mess it up. When you do your u sub, I got u is this and this. Let's do some of the highlighting. This guy is this one, and this is that. Notice this 4th power is not part of the u. So when I do my u substitution, whoops, I get the integral of du over u, but then I need to leave that 4th there, which it might be easier to think about this as the integral of u to the negative 4th du, which gives me negative 1 over 3 u to the negative 3, which is negative 1 over 3, and maybe we'll put the negative here, open parenthesis, or sorry, u cubed plus a constant, right, my plus c, and then I can sub my u back in, which is this one right here. So I get at the end negative 1 over 3, open parentheses, 5x squared plus x, close, oops, not squared, cubed, plus a constant. All right, so let's do example 5. This one, I want you to try. Integral, actually what I'll do is erase this and put this back in, and I want you to do it. We'll do to the 7th. See if you can do this one. Integral fraction bar top, 10x plus 1, bottom, 5x squared plus x, raised to the 7th. So go ahead, hit pause, and try it. Here comes the answer. All right, boom. We got this. It's du in the top, u to the 7th. Write it with a negative exponent. Do some power rule. Simplify with that exponent, and then plug the u back in. Negative 1 over 6, open parentheses, 5x squared plus x to the 6th plus a constant. So I'm going to do one more video, I think, and then you should be pros at doing this ln integration.